So welcome. My name is Mark Waterman. I'm the Electronics Division Manager for ECD. I've been with the company for 15 plus years, and I'm passionate about profiling. Today I'll be doing an overview of our OvenSENTINEL product. We will show you the basis of its operation, some of its key features, differentiators, how it's used, the hardware that's included with it, and why you would want continuous monitoring. So what is it? It is a continuous product quality monitoring system. It provides a unique traceability record to every board that goes through the oven, if it has a barcode or unique identifier, such as RFID. So we can associate the oven condition, translate that into process parameters, monitor both the quality of the processing of the board and the product of a traceability record as it goes through the oven. It can be retrofitted onto existing lines, used ovens, or added to new ovens while you're adding lines. Principles of operation: it continuously monitors both zone temperatures in every zone of the oven and also the conveyor speed, which is time. And from that extrapolates a profile based on those conditions. We start with a target profile from a real board with real thermocouples on it. We take a snapshot of the oven conditions that created that profile. And then using our prediction algorithm, we say if the oven stays the same, then this reflow profile should stay the same. And if the oven does change, then we can predict with our algorithms how that oven change transfers into a process change. And what makes our product unique is that we have these, what we call extended sensor inputs. Those extended sensor inputs can monitor more than just time and temperature. We can now put sensors in to measure things like inerting, O2 ppm, convection via fan speed or air pressure. We can look at consumption rates for nitrogen to drive business analytics, exhaust stack pressure to help better refine our maintenance schedules. So these extended sensor inputs, along with the way that we track the board in time through the oven, is what we call true profile, and it's why we create a better traceability record than our competitors. As you can see, we track this board in time through the oven, and we apply the zone temperatures to this dynamic profile for the zones when the board is actually in the zone. I've got a better graphic of that may better illustrate that here. And so as the board travels through the oven, we record the temperature of the zone as the board is passing through it. And then we dynamically build this profile as it goes through the oven, so that when we get to the end, we have a single profile that is either in spec or out of spec. At that point, we flag it as okay or not okay, and then we save it to our SQL server. How is that different than our competitors? Other systems out there will take snapshots. Every 30 seconds, it will take a snapshot of the oven, and it'll say the profile's okay. So during a 5-minute period, you may get 10 snapshots. If all 10 of those profiles are in spec, then the board is okay. The problem comes in to play when we have 10 profiles. That means we have 10 slightly different peak temperatures and 10 slightly different time above liquiduses. And the auditor will ask you, well, which one's the right profile? And the right answer is, well, none of them are really correct because they weren't taken, the temperatures in those zones weren't taken when the board was in that zone. So we do it by collecting the temperatures as the board actually passes through the zone. And that's what makes our dynamic profile better and more appropriate to the process. We talk about these extended sensors and what the heck is Modbus? Well, Modbus is simply a serial data communications protocol. You can hang many sensors off of one set of cables, and it was originally developed by Schneider Electric back in 1979 to initially program and talk to their PLCs. It quickly became the de facto standard for factory automation. So there's literally thousands of sensors available that can speak through this serial interface, which we can input into our system. We put alarms and warnings around it. We can do SPC on it, and we can add it to the traceability record of that product being produced. Traceability and process control is really an insurance policy. Of course, it pays dividends initially because we can stop production if we find an out-of-spec condition. Maybe the more valuable side of it is that we can quantify how big a problem there was in the past by continuously recording. We can tell you if a problem existed for 5 minutes or 5 days, if you produced 7 boards incorrectly or 700 boards. And being able to quantify the size of a problem has a huge payback after the fact. It also helps to feed other systems for business analytics. And of course, the traceability record. Why do we need traceability? We need to prove that these things were produced correctly in spec, and we need to prove that every board was produced correctly and in spec. We know that the automotive has active safety systems. There's a huge liability component with that. You know, aircraft, aerospace, medical. These devices are all things that have life safety involved, and they need to have absolute assurance that they were produced correctly. One example of how traceability can actually save money is an example from General Motors. Back in 2013, they had some Chevy Volts that had a peculiar problem. Their brakes would just lock up spontaneously. It didn't happen to a lot of cars, but they found it in a couple, and they needed to find out how big of the problem was. So using their track and trace and traceability system, they were able to identify what the problem was in their manufacturing, find out that it wasn't an entire production run that was bad, that they limited this down to only having 4 cars that potentially had this problem. And so you can imagine the scale and the cost of dealing with a problem on 4 vehicles that you knew the VIN numbers, you knew where they were sold and who bought them, compared to an entire production run of vehicles that may be 15, 25,000 vehicles out in the field that you would have to track down and potentially modify or replace parts on. So orders of magnitude in cost savings and complexity to be able to quantify that this problem only affected 4 cars. So why is our system better? What's flexible about it? Well, we use our map software, which, if you're not familiar with, is very flexible. It's template driven. We can have as few as 1 channel up to 20, so it's very data dense. We have customizable calculations, and you can add virtually an unlimited number of them. Each one of those calculations can be tailored to requirements for components, requirements for your solder paste, end user requirements. So all those calculations can be built. We can put warnings and alarm limits around them and do SPC on them. So we use our map software as the foundation of our flexibility, because we really can just about extract any type of data from a temperature time plot. Then we go one step beyond that. We have these extended measures that we absolutely know affect the reflow profile, like fan speed or convection rate. Now we can put a sensor around that, and we can monitor it and measure it. The exhaust pressure, we know that. And if your process requires, a new process requires some measurement that isn't currently available on your 5-year-old oven, we can add it. If vibration becomes a critical part of your process, we can put a vibration sensor on your conveyor rails. We can plug that into OvenSentinel and now add that to not only our database, but to the traceability record of the products that you're producing. And then we add automation to it. Automation, so we've added in the startup and changeover mode, which we'll talk about a little bit more. But once we select a product and start recording, the operator can walk away. Or once we sense a barcode to do a product changeover, the system takes over by itself. We will clear the oven of any product that's currently in there. We will wait for the oven to stabilize at the correct temperatures to meet the parameters of the product that we're changing over to. We can even put in a stability time lag. So if we want to wait 5 minutes after the oven stabilizes to make sure it really stabilized, we can do that as well. When everything has passed our criteria, we automatically start running the product. We open up Shmemo, we allow boards to go in, and then we continuously monitor the process from that point on. Same with changeover via barcode or an operator. We don't have to wait for the oven to stabilize before we start recording, which was always a problem with our older systems, is that the operator would start a changeover, they would get the oven going on a new recipe, which may take 10 or 15 minutes. And in the meantime, they couldn't record with the continuous monitoring system because it would constantly be an alarm, and they'd have to silence it and silence it. So they would just not turn on the continuous recording. And then the oven would get ready and production would start coming down the line, and they would start running product without recording, which left the possibility open that you could have an excursion. You could go out of spec, and that those products that were being produced may not have a traceability record if you needed them. And so we put in this automation to make it easier for the operators. They can do an oven changeover and a continuous monitoring changeover at the same time, and it's fire and forget. They don't have to remember to go back and turn it on. And they don't have to worry about it allowing production before it's in specification. If something does go out of spec, if we do have an excursion, we have a very flexible way of alerting the operators to that. We can custom set up the level of attention we want to get by product. So if we have a very high reliability product that absolutely has to be done correctly, we can put very tight spec limits around it, and we can tell the system that we want the lights to go off, we want a horn to go off, we want to stop production, and we want to send out an email. We're going to call in the cavalry. We need to have it inspected, verified, made sure it's back into specification before we continue running. If maybe we have a less of a need to call in the cavalry, and maybe we just want to have a process engineer look at this and make sure it's okay, we can simply turn on a yellow light and send an email. We're not going to stop production. We're not going to turn on a horn and get everybody jumping out of their chairs. We're going to send a simple email and alert them to what the problem is that shows why we're in alarm, and then we can add notes. So this is just a way to annotate, to mark down why this excursion happens. So here you can say, oh, I forgot to change the recipe in the oven, or recipe was changed accidentally. And then you can save that to the database. And then when your quality guy goes through and starts looking at how many excursions we had, you can start building a database of why those happened. Cost savings from time savings. We have what's called a one-button profile. So we're taking a snapshot of this profile of the oven conditions every 10 seconds or every 30 seconds, depending on what you want to set it to. And because we have these extended measures along with it, and it makes a better dynamic profile, we can now hit a single button and produce an XMG that we can do analysis on in MAP. We can use it as our incremental profiling. It doesn't eliminate the need to put thermocouples on a board and run it through the oven occasionally, but it greatly reduces it. We know that profiling takes up human time, it takes up machine time, it can interrupt production. So being able to get these incremental profiles out, documentation or proof that you're monitoring the process, is a huge time saver. It quickly builds the ROI argument for the system. We automatically generate not only profiles, but all the SPC that goes on around them. If you've got quality people that like to work in mini tabs and do SPC charts, that's great. But maybe you don't have that level or need. We can generate those XBAR R charts for you automatically in our software. We have two levels. We have a live version to do quick analysis for troubleshooting, and then we have a more in-depth report version that looks at a larger sample sizes and over longer time periods. We do SPC on everything that we collect for our MAP KPI calculations, for any of our oven conditions, including our extended measures. Traceability, our barcode features, best in class, both in functionality and in automation. So we have up to 2 barcode scanners that we can input. Those can be used to validate barcode numbers. So we can do validation that it's the correct barcode. And we can do that with prefix, with suffix, with contains. We can have a list from a database of valid serial numbers. We can also use a regular expression for you IT people out there to be able to validate a barcode. If we get an invalid barcode, we can stop production from happening. We can say, why is this here? Either it doesn't have a barcode or it's got the wrong barcode. It needs to be either addressed with the laser marker, or we're doing a different production run and the system isn't aware of it. For automation, we can use 2 barcode inputs, one for, say, a part number and a second one for traceability. So we can use one for automated changeover, and then the other one would get the unique identifier ID, and we would use that for its traceability record. We support dual lanes, so if you have 2 barcode readers, we can use it for automation and or traceability on each lane. And then we even have the ability to distinguish the same barcode between 2 readers, and we use this for top and bottom differentiation. So if we're processing a board on the top side, reading it on barcode reader 1, it's product A top side. And then if we see that same barcode on barcode reader 2, which is mounted on the bottom, we know that that's a different product. We're running that board on the second side, which may have a different recipe. It can have different alarm and spec limits. And we can actually process that like an entirely second product. And we're able to quantify whether that barcode was read for top side or bottom side, which is unique in the industry. A quick overview of what you get in these different kits. Our basic kit gives you everything you need for traceability and true profile. It gives you the station, the status badge, a custom probe, a board sensor. We need that to be able to track when the board entered the oven so that we can track it through in time, how it goes through the oven. We measure conveyor speed through an inductive sensor, which is pretty standard in the industry. And then our software, of course, that we've been talking about. If you go to the full kit, we add some extra sensors to add features. So we have a board exit sensor that helps us drive our board drop detection if that's a critical measure or a critical alarm or alert for you. We have a pre-barcode sensor that basically sets a timer. We sense a board, and then that timer is set to, if we don't read a barcode within a certain amount of time, we'll set off the alarm and we'll stop the board from entering the oven. This is if we have a malformed barcode, something that's unreadable or defaced or potentially missing. We're able to take that and either put a barcode on it or take it out of production so that no more value-added activity happens to it. You get a light tower and a SHMEMA interface. That's how we stop productions with SHMEMA, to stop the ECD conveyor from allowing boards into the oven. If you get a dual kit, if you have a dual lane oven, the software supports dual lane ovens natively. You just get a second set of those board sensors for pre-barcode oven entry and oven exit, and then the second SHMEMA interface to control SHMEMA on the second lane if you have a dual conveyor. And then if you're an existing oven watch user, all the hardware sensors that we input into our oven watch system are 100% compatible with OvenSENTINEL. So all you need is the station, some software, and a status badge, and you can upgrade your existing oven watch kit to an OvenSENTINEL system. So you get all the improved software features, all the improved automation at a very affordable rate, because we don't have to add all that extra hardware. We don't need a new custom probe, etc. So what's different about our hardware? Well, our hardware is more advanced than our competitors. We have more inputs, up to 59 total, 24 temperature. We have some 3 multifunctional digital with frequency and period, and I'll explain the difference with that in a second. And then, of course, our serial and our Modbus, which gives us our extended sensors. So why is period and frequency important? Well, most systems use period. We look at 10 pulses per second or less, and we're measuring the time between those pulses. That is the period. And it is, for the most part, it's an okay measure as long as you don't have a very fast input rate. For some of our ovens out there, they do have a very fast input rate that may be over 10 cycles per second. And at that point, we can measure frequency. And that frequency measurement is very accurate for conveyor speed, and it allows us the flexibility to integrate this into ovens better than some of our competitors. We give you a display and diagnostics menu on this station. So your service guys, your technicians that have to support and maintain this system, They can get in there and exercise all the outputs, turn them on or off, check the light tower, make sure the horn works. They can see all the inputs from all the barcode sensors, from the barcode readers themselves. They will display that for you. If you need to have your system calibrated, it's got an automated calibration routine built in. It's menu driven. You plug in a standard with a special harness and then run through a calibration routine. So we've thought about supporting those service technicians and the maintenance guys out there as well. Communication is via a standard network cable. We can be on a house network, or we can be peer-to-peer, direct connect with a PC. So it doesn't have to be connected to a network to function. Our zone probe is custom made in-house. We tailor this to each oven, and we do that because we want to target the location where we measure the zone temperature. We put the thermocouple exactly in the middle of every heated and cooled zone, and we try to put it on the movable rail, so we're closest to the action on the board. We also only record real data. It's not being massaged or averaged in any way. Some of our competitors will use 30 thermocouples. Well, that must be better than 12 or 9. Well, not necessarily, because they aren't necessarily in a strategic area for measuring the temperature of that zone. They may be getting influenced by adjoining zones, and they aren't providing real measurements. They're taking maybe 2 or 3 thermocouples that are in this zone, and they have to average it together and massage it. So even the data that they report is not a real measure. It's a massaged measure. So instead of using a shotgun, we are more like a sniper. We choose the absolute best place to measure the zone temperature, and we do it in a targeted fashion, which we think is better, less maintenance, less massaging, and the data that we're reporting is real. Our status badge. Why do we need a status badge? Well, even with the basic kit, you get this status badge, and it's end-on. It's a visual representation of the system's state. You know, if we're green, we're actually recording. It shows that we are recording and that we're in specification. So a quality guy can see from across the room, oh yeah, they're using the continuous monitoring system. If it's in warning or alarm, of course, the yellow or red. What else is this used for? Well, when we put our light tower on, it's usually very close to the oven's light tower. And we found through experience that the operator sometimes have a hard time identifying when there is a problem. Is it coming from the continuous monitoring system, or is it coming from the oven? Well, this is another way to visually show that it's either our system or it's the oven. And it's a direct feedback to the operator. Again, trying to make it easy for them to use and take as much confusion out of the process as possible. We have an optional PC that we can preload with our OvenSENTINEL software. It's a business class Dell Optiplex PC, micro form factor, so it fits into small hidey holes. It is business class, so it's guaranteed to work with other applications, Windows 10 standard, has a solid state hard drive. We also include a HDMI KVM switch so that we can share your keyboard, screen, and mouse with your oven computer. If you choose to put this on your own computer, that's perfectly fine. We'll let you do that. We just ask that it's business class. Don't try to go with a $100 Celeron processor and lowest common denominator. Because this is a traceability system, we want the reliability of a business class PC to run our database on. So how the system works, this will be a high-level overview of what you would actually do if you wanted to implement this and use it. We would take our map software and get an initial profile. This has to be with thermocouples that are on a real board, populated, that's run through the oven. We can use 1 channel, we can use 20 channels, depending on what the needs of our customers are. Again, we can be as dense as we want, and we can have as many calculations as are needed. If you only are interested in 3 calculations, just put those 3 on and leave the rest out. If you need 20 calculations on there to appease your customer's quality guy or to maintain your own quality system, put all the calculations on you want. We'll use them in our continuous monitoring. So once we get that golden profile established and we're in spec, everything is the way we want it, we then go to our OvenSENTINEL software. We take that golden profile, we import it in, we can configure our alarms and warnings. We can also warn on CPK limits. So if we start to see a trend go out of control, we can warn you on that as well. And then we apply our probe temperatures. And this is the marriage between this golden profile, this is the way this board heated, and here's the oven conditions that heated it. So we marry those two together and that becomes a product. Once we have that product, it's very simple to utilize the system for continuous monitoring. The user operator would come in, we would have a list of active assemblies. We would choose the one that we were going to start recording, and we would hit the start recording button. Once that happens, it goes into its automatic startup or changeover mode. And once the oven was in specification and ready for production, it would allow boards to enter the oven, and it would go into our rotating carousel. This is our live recording data set, and the 3 different pages that go through our live profile data, which gives you our KPI table and all of its calculated measures, gives you a visual representation of this thermal plot or profile, and a visual cue of the actual product itself. And this is, again, helps the operator see that, yes, the product that I'm recording, that looks just like the board that went into the oven, everything is good. If you had a board that was going into the oven that didn't look like this product, that would be a cause for alarm or a call to action. We have our live oven data. So we show you things like the zone temperatures and conveyor speed, and also our extended measures. So you can see these cute little gas gauges down here. They have red, yellow, and green on them. So you can see if they're starting to get close to a warning limit. And these can be anything that is needed for your process. So it really goes beyond the time and temperature profile. We have live board tracking. You can see here in this representation, this is a dual lane oven, and it shows which boards are in each lane. We show the number of boards processed, and we show the exit time for each board that's in the oven as well. So an operator can quickly, if they need to, see when a board is going to, the last board is going to come out of the oven, so they can go on break potentially, or they can do a changeover or maintenance, which is nice. And then we have our live SPC. So this, we can toggle in a live fashion while we're recording through all of our different machine measures, through all of our process measures, including our extended measures. And we can adjust the sample size and subgroup. Why is that important? It's important when you may want to do some quick troubleshooting. If you suddenly have a warning that your peak temperature has gone above where it should, or let's say below where it should, we can quickly look at our live SPC and check the zone temperatures for the last 2 heated zones and the conveyor speed to see if they're all stable and if there's any trending down or up. So we can use it to quickly troubleshoot a process variation live on the fly without having to stop recording and go into reports and delve into the data that way. We can quickly look at these control charts live as they're being recorded. And then subgroup size. Why do we care about subgroup size? Well, if we have a subgroup more than one, we build control charts for you. And we calculate those control limits on the fly, live. And if we go to a subgroup of 1, an individuals chart, it suddenly becomes a spec limit chart, and we can calculate CP and CPK for you. So if you want to know the CPK of the last heated zone in your oven, you can quickly put in the subgroup size of 1, look at the last 25 samples, and get a value. If you want to look at the last 100 samples, you can do that as well. So it's meant to be able to quickly extract SPC data on the fly for immediate use. We have reports that go in depth into SPC when you're offline, or when you want to look at larger sample sizes beyond 100. and that's in our reports. So we have many reports. So I'm just going to do a high-level overview on a couple of them. Our true profile report, this is per board. So if you have a barcode with a unique identifier, we can actually pull up that unique identifier and provide a profile for each board that's gone through the oven. And it will have a representative graphical profile. It will have our KPI measures. It has our extended measures if we have those set. It has the recipe of the oven that produced it. And this can be produced, like say, for every board that's processed. It can have its very own profile. We can do some product summaries. This is good for both quality in a macro sense. We can look up a specific product in a specific date range. We can show how many boards were produced in spec, how many were produced out of spec. We'll calculate defects per million opportunities for you. And this is something that you can give to your end customer. So every time you do a production run, if you don't want to give them a unique traceability record with each board, you can at least give them a product summary at the end of every month showing that, hey, I monitored all your products and they were all within spec. Even if you don't have traceability, it still will have a unique board identifier that the system gives it, and you can say we processed 411 boards, they were all produced in spec, here's your report along with your bill, thank you. So it's a nice report that you can give to your customer. And again, that adds value to the end customer. It protects their brand. It gives them the warm blanket that says that you are on top of your quality program. And we can do SPC on anything that we record, be it machine measures, process measures, extended measures, product specific measures, true profile, that it's all extractable. The other thing is we've gone to great lengths to make our database very accessible. So we've put in human readable views. This means that we use plain English to describe, peak temperature, channel 1, 250 degrees. So it doesn't take a decoder ring to figure out where this data is stored or what data is contained in it. And so that can be easily customized into your own dashboards, to your own customer reports, or integrated into your MES system. So what's the ROI? Where did the savings really come from? Well, a big part of that is the reduced need to profile. I know that everyone that's in the industry can't wait to hook thermocouples up to a circuit board, interrupt their production, and run this through their oven. I get excited about it, and I'm probably the only one in the world that does. So with continuous monitoring, because we're monitoring all the parameters of the oven, there is a reduced need to do that, to double check as you would with a real circuit board. And we have a one-button profile now so that we can produce a profile at the click of a button without interruption. Our automation reduces the operator's interaction, the need for them to babysit the system, to wait for the oven to get ready before they start recording. So it reduces the amount of operator time needed to have this system working for you. And engineering time, like say, we can quickly do diagnostics, we can quickly look at SPC to get insights into the process if we're having a deviation. We can do export large SPC reports to save the time of that process engineer who may need to do that. Downtime in the machine, when we talk about downtime, we look at two faces of that. Downtime that you would have from profiling, that's production interruption. And also we're helping to feed with our extended measures the quality of our maintenance programs. So you may need to increase maintenance frequency or decrease it. But without having that data to analyze and look at, you may not know which one. And we talked about feeding the Industry 4.0 initiatives. Again, you need huge data sets, and you need to capture mistakes to really get the benefits of Industry 4.0. And because these systems are so reliable and don't vary very often, you need to record them for a long time to get enough data to really feed those systems properly. And then probably the age-old thing is, because we're constantly monitoring the process, you're going to reduce scrap, because if there is an excursion, we're going to stop production. We're going to let you know about it. The oven itself, things do fail, and when they do, sometimes it's not obvious. You can have blower fans go out, you can have heaters that go out, and your oven may not complain about it, but our OvenSENTINEL would. So you're able to catch those small changes in the process and stop production before those products make it out into the field and fail and potentially cause either liability risk or directly from human safety issues, or just from loss of brand, which can be just as costly. And then we talked about error proofing. Unfortunately, most of the errors that happen in manufacturing are caused from people or process. So by having a process that's easy to follow, and by eliminating the need for babysitting, an operator can fire and forget, and we reduce the chance for error in the system. Ultimately, it protects the brand and adds value to the end customer. It's something that they see value in. It's something that you can sell as a value, because you can offer that proof that you're on top of your quality system. So easy to use, powerfully robust, unequaled flexibility, data density, traceability, and automation. We just do it better and more complete than our competitors. Our map software has more flexibility in its calculations. We measure more than just time and temperature in the zone. We measure extended measures of potentially O2, ppm if you need an earthing. We measure convection features such as fan speed or air pressure. We can measure maintenance issues like exhaust flow, exhaust stack pressure. We can measure power consumption. Literally anything that is important to your business analytics group or to your quality group, your process engineering group, we can add sensors to it. We can collect the data. We can do SPC on it, which is unique in the industry. Our automation, again, makes it easier for the operator. If you can implement this system and not make it hard for the operator, it will get used. And when it gets used, it has the most value. One button profiling, again, saves both machine time and operator time. We can produce a profile at the click of a button now, instead of running that circuit board through and interrupting production. Our industry standard, industry proven SQL database is easy to manage and integrate. We have human readable views, so you can get information out of it and integrate it into other systems. We're not an island of data. We can easily integrate to MES systems. If you have an IT group, this is their job. Write an SQL query to get this data out and put it into your MES system. And then our advanced hardware. We are a third-party verification. We're independent from the oven. When you have a built-in monitoring system, it's kind of like the fox watching the hen house. They are going to present data to you that best reflects their product. And that is just something you do by nature. Because we are third-party, independent, we will show you everything that we record, good, bad, and ugly. If you have board loading issues when you run heavy boards, we're going to show you that. And if that board loading causes out-of-spec conditions, we're going to stop production, we're going to turn on the red lights, and we're going to bark at you for it. And the oven manufacturer may not want to show you that side, but we will. Extended measures, the only system that takes convection into account. If we know that convection plays a huge part in reflow, that's how well the oven can press that ambient heat into a product. That's via fan speed or air pressure. And now we can put measurement around it. We can quantify it. We can put a spec limit around it. We can warn or alarm if it changes. So really a next level of continuous monitoring. We look out for the technicians, for the service guys out there. We made the hardware easy to manage and maintain, right? We give you a display, we give you automated calibration routines. We made it easy for you to put this into your maintenance schedule. Our status badge, not only is it there to show that the system's working, but it's also there to eliminate confusion for your operators. So unique. It also gives us a little bit of branding, by the way, too, which we like. So that being said, ECD advantages. We are your trusted third-party verification. We've been in the business for 35 years in thermal profiling, longer than that in electronics, but we pioneered the industry. We know what we're doing, and we enjoy what we do. We are the industry leader, the premier provider for data collection and validation. We're very involved in the industry. We understand the needs of manufacturers. We were a manufacturer for a lot of years ourselves. So we have a unique insight into what's needed and how to best implement it into your manufacturing processes. And as we say, okay, well with that, I want to thank you for attending today. If you have questions or you want more product information, please feel free to contact us. The contact information is down here in the lower left. We'd be happy to supply you with more information, brochures, live software demos, whatever you need, we can provide. Again, thank you for your time.